In this video, I'm going to be sharing with you 4 key insights that I learned as a software developer working for one of the largest tech companies in the world, Google. You'll be able to take these insights to become a more meaningful contributor to your team if you're already a software developer. And for aspiring developers, this will give you insight into what working at a big tech company is like, and you'll be able to use these insights in your own code. Now, one of the perks of working at Google is that there's tons of internal documentation about how to be a better programmer. This is because Google's core asset is the code that it owns and the processes surrounding the production and maintenance of that code. These 4 insights will break down the best learnings that I got from my time at Google. Okay, let's dive in. Insight number 1, code is meant to be read by other humans. One of the first documents that I came across at Google was about best practices as a software developer. It argued that in most cases, you want to optimize your code for readability. And what is readability? It's your code's ability to be comprehended. It can be counterintuitive, especially for beginners, because all we're really focused on is getting the machine to do the right thing. But if you think about it, much of a software developer's job is to add to and subtract from and maintain existing systems. And we do this by adding features, change existing features, and fixing bugs. In order to do this well, we have to first comprehend what the system does, and it's this comprehension that can take a really long time. This process is like loading up our figurative brain RAM so that we understand what the program actually does right now. And the harder it is to load this context into our brains, the longer it takes to contribute. Especially if you're working on a mature system that's been around for a long time, most of our job is actually going to be about reading and comprehending code, not writing new features. This means that creating readable, easy to understand code is a real productivity asset. As a front-end developer, I'd often do things like take annotated screenshots of the user interface to explain parts of the code that were pretty hard to understand. And then one day I had a coworker specifically call out that all they needed was that screenshot to understand the complex code, and that it saved them a ton of time in understanding the context. Over time, it's very common that multiple people on your team will be reading your code to understand what it does. So if you compare 2 scenarios, let's say in scenario A, you have 5 developers who take 30 minutes to understand a specific part of the program. And in scenario B, it takes each programmer 5 minutes to understand the context of the program. Now the total difference between these scenarios is 150 minutes of time spent on understanding versus 25 minutes of team time spent on understanding. That's a huge difference, all because of the readability of the code. And if you imagine repeating this process for multiple times a day for multiple developers, you can see why readability is a true asset to a software business. And this leads me to another insight that I learned. Self-documenting code is more important than documentation. For having an engineering culture that harps on readability and comprehension, I was absolutely baffled to find out that most of their tools had very poor documentation. Google's engineering team solved this documentation problem not with more documentation, but at a fundamentally different level. They built this best-in-class code searching tool, aptly named Code Search. This meant that as an employee, I could personally view the entire Google 3 codebase. And because this code search tool was so efficient and so effective, all I really needed to do was look at the code that I was trying to use instead of reading the documentation about the code that I wanted to use. And as long as everyone committed to writing self-documenting code, this worked out. So in practice, instead of having like a web page that explains a service's API endpoint, you could just take a look at the code and infer what the API endpoint does based on the method name and the expected inputs. The code itself was self-documenting. Although there were times that I wished that there was like a nice clean documentation page, if I were being honest, it was completely unnecessary because I could just quickly look at the code and see what it does. Documentation is only a valuable asset if there's no alternative for consumers of an API to understand what that API does. As long as readers can understand what endpoints are available on your API service and what inputs and outputs are expected, then there's no need for documentation. And this topic of self-documenting code brings me to another key insight. Insight number 3 is that I learned about the power of protocol buffers. At Google, we use this data interchange format called protocol buffers. Here's how the official documentation defines protocol buffers. Protocol buffers are Google's language-neutral, platform-neutral, extensible mechanism for serializing structured data. Think XML, but smaller, faster, and simpler. You define how you want your data to be structured once, then you can use special generated source code to easily write and read your structured data to and from a variety of data streams and using a variety of languages. We define our APIs and methods using these protofiles, and we'd let some build tool generate source code based on these protofiles so that we can call API endpoints as if they were just function calls native to the language that our app was written in. This meant that the data shapes that are used and passed around in our programs could be defined in these proto files. And data interchanged and sent over the wire between services could also be documented in the form of protos. There was no need to create API documentation for your API service because the proto file was literally the documentation. And the build tooling that generated code based on the proto files would work in a variety of languages, allowing anyone who was using any of these supported languages to call your API using protos. It goes to show you just how important self-documenting code actually is. Google's engineering team decided to create an entirely new data interchange format so that an API service would be self-documenting by nature through proto files. Insight number 4 that I learned from working at Google is that a programming language is just a tool to solve a problem on the job. During my time at Google, I worked in 6 different programming languages: C++, Java, Golang, TypeScript, JavaScript, and a little bit of Dart. As a front-end developer, most of my work was actually in TypeScript and JavaScript. But I had to touch some server-side code along the way for our web application, and that included C++, Java, and Golang for some of the build tooling. And to be honest, I was actually taken aback when I was asked to contribute in an entirely new language that I didn't know how to code in. At first, I had a lot of self-doubt, like, I don't know how to contribute in this language. I don't even understand what I'm writing. And I'm certainly not qualified to commit production-grade code to the Google codebase. But after my tech lead just began assigning me these tasks one after another, I realized that I had to contribute despite feeling self-doubt. You see, I had a lot of doubt, but there was not a single shadow of a doubt in my tech lead that I was fully capable of onboarding and learning this new language. And he was right. The situation forced me to learn new languages and get used to committing code regardless of my experience in a specific language. This process taught me the valuable lesson that a programming language is just a tool to solve a problem. As a beginner, which language you learn actually doesn't matter as much as how deeply you understand the language that you choose to learn. Because once you intimately understand one language, the lessons and programming principles that you learn through that language is going to translate really well into other languages. And as a seasoned developer, you probably already know this, but languages come and go. They're just a tool, and you just learn whatever you have to get the job done. Okay, so those are the 4 insights that I walked away with from my time working at Google. If you like this video, give me a like and subscribe to the channel for more videos like this on working in tech as a programmer. I also have a newsletter dedicated for people who are interested in transitioning careers into software development. I'll leave a link to it in the description below. Okay, see you in the next video. Bye-bye.